Okay, so this chapter talks about triangles, and in section 4.1, we're going to be classifying triangles. These are basic stuff that you learn in middle school. For example, on the first one, classifying triangles by their angle measures, and this is only by their angle measures, okay? We're going to classify them by angle measures and by the sides, but in this case, it's only by the angle measures. An equiangular triangle, so this is a term that we need to remember, equiangular, is a triangle with three congruent angles. So if you have a triangle with three congruent angles, the special name is equiangular. Then we have the classification, and on the classification we have acute triangle, and in this one all the angles are acute, less than 90 degrees. Right triangle, one of the angles is a right angle. Obtuse triangle is because one of the angles is obtuse. And then we have an example on the bottom. It says, you can use angle measures to classify the triangle JML, which is this one. Sometimes they're going to give you some information about the triangle, but notice that here we're missing an angle. But since we already learned in chapter 2 and in chapter 3 that a linear pair is when you add two angles, they form a line, and that is 180. So if one of the angles on one side of the ray is 120, then the missing angle would be what? 60. That is right, because it's 180 minus the angle given, which is 120, and that would be 60. So sometimes you're going to have to find the missing angles to classify the triangle. And in that case, that's an acute triangle. So here it says, since all the angles are congruent, God bless you, then the triangle JLM is an equiangular triangle because they're all 60. 60, 60, 60. So it's not only equilateral, it's not only an acute triangle, but it's a special triangle. It's an equiangular triangle. So let's go over the examples. Number 1, let's classify the triangles by the angle measure. So what's the first one?
Right angle.
It's a right, and you have to say triangle, okay? Number 2, what about the second one? It's an obtuse triangle because one of the angles, it's an obtuse angle. Number 3, it's an acute triangle because all the angles are less than 90, so it's acute triangle. Okay. Now we're going to move on to number 4. Seems like this is, let me just wrap this around. I'm just going to move this stuff. There you go. Okay. So now on the second part of this section, it says classify, it says each triangle by its angle measures. And notice that in this one, the first one, triangle DFG, D, F, and G, it's the big triangle. So how would you classify that big triangle? It's a right triangle because you have a right angle here. So it's a right triangle. The second one, triangle DEG, DEG. So I recommend that you kind of like highlight it or circle it, do something so you can identify that. So what type of triangle is that? It's an acute triangle. And the last one. When you go around and you classify EFG, E, F, and G. Are we missing something in that triangle? Yes. We need to know how much is that angle GEF. So how much is that angle GEF? How can we find that? 112? Okay, so how did you get the 112? Did you subtract?
180 from 60.
Okay, so you subtract 68 from 180, and that's 112. Okay, so once you know the measurement of that missing angle, 112 degrees, then we can classify that as an obtuse, right? Obtuse triangle. Any questions so far? Now we're going to classify the triangle by the side lengths. So you have to be very careful. You need to find out by what you're going to classify the triangle. This second part is being classified by the side lengths. So if it's by the side lengths, you can classify it as an equilateral triangle where all the sides are equal. They could either give you the tick marks or they can give you numbers. The same number around, that means that they're all equal. So it's an equilateral triangle. If it's an isosceles triangle, an isosceles triangle has at least two sides. So what do you mean at least two sides? Well, because if you have three sides, that's also isosceles. Okay, so an equilateral triangle is also considered an isosceles triangle because the definition of an isosceles is that you could have at least two sides congruent. So if you have at least two, or if you have three, that's an isosceles triangle. So be very careful. Remember that fact. When I give you an equilateral triangle, you also classify it as an isosceles triangle, okay, by the definition. And the third one, it says scaling. And the scaling is when you have no sides congruent. So all the numbers are different, no tick marks whatsoever. And in some cases, I'm going to go ahead and give you the triangle, and that triangle is going to have the tick marks, and you're going to have algebraic expressions. You just let them equal if they have tick marks, okay? So let's go ahead and try number 7. In problem number 7, it says classify the triangle E, G, and F. So by the tick marks, what can you say about that triangle? It's an isosceles. Isosceles triangle. The second one, DEF. D, E, and F. That would be a scaling. Why is that a scaling? No size congruent. That's right, scaling. And the last one. And the last one is DFG. D, F, and G. So what type of triangle is that?
Isosceles.
It's an isosceles. Okay, it's an isosceles because you have two tick marks here on the 20, and so this is 20 also. So it's an isosceles triangle, yes. Any questions so far? So far, so good. Okay, now number 10. Let me just move that out of the way. In problem number 10, it says find the side lengths of each triangle. So we have to find all the side lengths, okay? What they're giving me is that those two tick marks represent congruency. So therefore, you can say that 5x minus 1 equals 4x plus 1. Then we have to solve for x. What do you move first?
Move the x to one side.
You move the smallest x to where you have the biggest side. So which is the smallest x?
4x.
The 4x. So we subtract 4x. And 5x minus 4x is just 1x or just x. And then we get rid of the negative 1, adding a 1 to both sides. So x is 2. But they want the measurements of the side lengths. So should I plug it into both of them?
Yeah.
Sure, you could put them into both of them. But that should give you the same answer. 5 times 2 is 10 minus 1 is 9. And the same thing here. 4 times 2 is 8 plus 1 is 9. So the side lengths are just 9, 9, and 9. Okay. Now go ahead and try number 11. Find the side lengths of number 11, please. what is the x equals to, Gabriel?
I'm still looking at the problem.
Okay, what are you doing to find the x?
You put one of the sides on, you make an equation out of all the sides.
Okay, so what's going to be the equation that you're using?
I put 3x plus 4 equals x plus 6
That is right.
plus 2x plus 2.
Okay, but the only one that have the tick mark are those two, so we can only use those two to be equal to each other. Okay, so we use those two. Now, if I want to solve for x, what should I move first?
I will subtract the x,
You subtract the x, that's right, Gabriel. Great.
and then you subtract 4.
That is right. And when you subtract 4, you have
You divide by 2.
divide by 2. So what is x equals to when you divide by 2? That would be 1? Okay, so x is equal to 1. Great. And now person number 16. Who's 16? Is that you? Okay. Gabriel and Gabriela. Wow. Okay. So what are the measurements of the side lengths? What did you get for the measurements of the side lengths, Gabi?
I didn't finish that yet, but
Okay.
I did x plus 6 and 7.
That would be 7.
So the side length is
7, 7, because they have the same tick mark, right?
Mhm.
And what about the third side?
7. Wouldn't it be 17?
No.
6, 4.
So 7, 7,
4.
and 4. And those are the side lengths of the triangle. Yes. Any questions about these problems? So far, so good? Okay, now let's go ahead and move on to section 4.2, the second paper.